Right now, in a silence so complete that it has no proper name, a machine built by human hands is falling through the dark between the stars. It weighs less than a family car. It carries a slowly dying battery, a gold-plated record that perhaps no one will ever play, and a radio signal so faint that catching it is like straining to hear a single whisper shouted across an ocean. It has been traveling for almost half a century, and only recently did it cross the invisible shoreline, where the wind of our own star finally gives out. Beyond that shoreline lies true interstellar space, a place no object made by living hands had ever touched, until this small, stubborn traveler arrived. And here is the thought that steals the breath from your chest, even moving faster than any bullet ever fired. That spacecraft would need more than 70,000 years to reach the nearest star to our own. It will run out of power long before then. It will go cold and blind and mute, still coasting outward, carrying our fingerprints into a darkness that does not end. If a story like this stirs something in you, take a moment to like this video and subscribe. It genuinely means a lot to us, and it helps these journeys reach more curious minds. That distance is not a number the mind can truly hold. We say the words light year as if they were ordinary, but a single light year stretches nearly 10 trillion kilometers, and the nearest star sits more than 4 of them away. When you look up on a clear night and pick out a bright point of light, you are not seeing that star as it is. You are seeing it as it was, when the light left it, years or centuries or thousands of years ago. Some of those pinpricks poured out their glow before the first cities were built on Earth. A few of them may have already died, collapsed, or exploded, and yet their final light is still crossing the void toward your eye. A message from something that no longer exists. To look at the night sky is to look backward in time. Every glance upward is a kind of memory that belongs to the whole universe rather than to you. We tend to think of the sky as a ceiling, a flat dome sprinkled with lamps. It is nothing of the sort. It is a bottomless well, and the deeper you fall into it, the stranger and more magnificent it becomes. Between you and those distant lights there is depth beyond depth, layer beyond layer. Worlds and furnaces and graveyards of stars stacked so far apart that light itself grows tired crossing the gaps. And in all that depth, on one small ball of rock and water circling one unremarkable star, something extraordinary happened. Matter woke up. It arranged itself into creatures that could look outward and ask what all of it meant. That is the quiet miracle at the center of this whole story. The cosmos is enormous and mostly empty and often violent. And somehow, from that vastness, there came eyes to see it and minds to wonder at it. Let us begin close to home. Though even close is a lie the moment you look carefully. Our star, the sun, is a sphere of glowing gas so large that more than 1 million Earths could be packed inside it. It is not solid. You could not stand on it. It is a churning ocean of plasma, a furnace where, in the crushing pressure of its core, atoms of hydrogen are forced together so violently that they fuse into helium and release a flood of energy. Every second, the sun converts around 4 million tons of itself into pure light and heat. That light climbs upward through the dense layers of the star for a journey that can take tens of thousands of years, bouncing and scattering, before it finally bursts free from the surface. Then, it crosses the emptiness to Earth in just over 8 minutes. The sunlight warming your face left the sun before you finished reading this sentence, and it is already old by the time it arrives. Around this furnace, worlds move in long, patient circles. The 4 inner planets are made of rock and metal, scorched Mercury, cloud-smothered Venus, our own blue home, and rusted red Mars. Then comes a scattered belt of asteroids, the leftover rubble of a planet that never formed, and beyond it the giants take over. Jupiter is a world so massive that all the other planets could fit inside it with room to spare. A striped monster with a storm larger than the entire Earth that has been raging for centuries. Saturn wears its impossible rings. Sheets of ice and rock spread so wide and so thin that if you could shrink them to the width of this page, they would be thinner than a razor blade. Farther out drift the cold blue worlds, Uranus and Neptune, wrapped in freezing winds, and beyond them a vast, dim swarm of icy bodies, where dwarf worlds and comets wait in the twilight. We forget how empty this all is. In every diagram we have ever seen, the planets crowd together, neat and close, because otherwise they would be invisible dots on an enormous blank page. The truth is that the solar system is almost entirely nothing. If you shrank the sun to the size of a grapefruit and set it on a table, Earth would be a grain of sand 15 meters away, and the nearest neighboring star would be another grapefruit thousands of kilometers distant. The spaces between things are the real subject of astronomy. We are specks separated by oceans of dark, and the fact that we have managed to fling machines across even a corner of that dark is one of the strangest achievements our species has ever attempted. Consider what it took just to leave. To escape the grip of Earth, a rocket must reach a speed of roughly 40,000 kilometers per hour. To break free of the sun's grip entirely and sail into interstellar space, it must go faster still. Every gram lifted off this planet has to be paid for with a violent, controlled explosion, a tower of fire balanced on a column of burning fuel. The early attempts failed again and again. Rockets tipped over, tore apart, blossomed into fireballs on the launch pad. And yet the dream did not die, because something in us refuses to accept that the sky is a wall. Slowly, through arithmetic and courage and an enormous amount of failure, the wall became a door. The first living things we sent up were not people. They were insects, then small animals, then a handful of brave and frightened test pilots strapped to the tips of machines that had, until recently, been exploding regularly. When the first human finally rose above the atmosphere and looked down, he saw something no one had ever seen with their own eyes. The whole curve of the Earth, blue and luminous, and terribly small, wrapped in a skin of air so thin that from orbit it looks like a faint blue haze clinging to the edge of the world. That thin haze is everything. It is the only thing standing between every living creature and the freezing, airless dark. From space, the fragility of it is impossible to ignore. Astronauts often come home changed by that single view, quieter, gentler, haunted by how delicate the whole arrangement really is. But orbit is only the doorstep. The moon is the next stone in the path, and it is far more distant than most people imagine. You could line up every other planet in the solar system, side by side, in the gap between the Earth and the moon, and still have room left over. When human beings first crossed that gap and set foot on another world, they did it with computers less powerful than a modern greeting card that plays a tune. They navigated by hand, made split-second decisions with fuel running low, and touched down on a gray, cratered plain that had not been disturbed for billions of years. The footprints they left are still there. There is no wind on the moon, no rain, no weather of any kind to erase them. Barring a stray meteorite, those prints will outlast every monument ever built on Earth. Long after our cities have crumbled to dust, a set of boot marks will still sit quietly in the lunar soil, evidence that a species from a nearby planet once walked here. The moon is a strange and telling world. It has no air to breathe, no liquid water on its surface, no protection from the fierce radiation of space. During its long day, the surface bakes hot enough to boil water. During its long night, it plunges to a cold that would freeze the breath in your lungs instantly. And yet the moon is not lifeless in the way we once assumed it must be. In the permanently shadowed floors of craters near its poles, places where sunlight has not fallen in perhaps 1 billion years, there is ice. Frozen water, locked in the dark, delivered over the ages by comets and asteroids. That ice matters more than it might sound, because water can be split into breathable oxygen and rocket fuel. The moon, once dismissed as a barren rock, may one day become a way station, a place to refuel on the long road outward. Beyond the moon lies Mars, and Mars has always been the world that whispers to us. It is close enough to reach, hostile enough to challenge us, and just familiar enough to break our hearts a little. It has seasons. It has polar caps that grow and shrink. It has a day almost exactly as long as ours. Stand on its surface, and you would see a sky the color of dusty butterscotch, a small pale sun, and a landscape of red rock and rolling dunes that would look almost like a desert on Earth, if not for the fact that the air is too thin to breathe and cold enough to kill. But Mars was not always like this. The evidence is carved into the planet itself. There are dried river valleys, ancient lake beds, minerals that only form in the presence of water, and vast channels that could only have been cut by enormous floods. Billions of years ago, Mars was warmer and wetter, with rivers running across its surface and possibly a shallow ocean covering much of its northern hemisphere. And then, something went wrong. Mars is smaller than Earth, and smaller worlds cool faster. As its molten core slowed and stiffened, the magnetic field it once generated faded away. That field had been a shield, deflecting the constant stream of particles blasting outward from the sun. Without it, that stream began stripping the Martian atmosphere away, molecule by molecule, over hundreds of millions of years. The air thinned. The pressure dropped. The water could no longer stay liquid on the surface. It froze into the ground or boiled away into space. A living world, or at least a world that might have been on the edge of becoming one, slowly suffocated. Mars is a warning written in rust across an entire planet, that habitability is not permanent, that a world can lose everything, that the difference between a garden and a graveyard can come down to a few degrees and a fading magnetic heartbeat. This is why we send machines crawling across the Martian surface. Robotic explorers, patient and tireless, roll across the dunes, drilling into rock, tasting the soil, photographing the sky, searching for the faintest chemical signature that life might once have stirred here. They have found the ingredients. They have found ancient organic molecules, the carbon-based building blocks that life on Earth is made from. They have found that the old lake beds contain exactly the kind of chemistry that could once have supported microbes. They have not, so far, found life itself. But every year the case grows more tantalizing, and somewhere in the sealed sample tubes waiting to be brought home to Earth, there may be an answer that changes everything we believe about how common life is in the universe. But if life is out there in our own solar system, the most promising places may not be planets at all. They may be moons, and they may be hidden beneath ice, far from the warmth of the sun, in the frozen outer reaches. Several moons hold a secret that overturned everything we assumed about where life could exist. For a long time, we believed that life needed sunlight and a comfortable position near a star, in a narrow band we called the habitable zone, where water can remain liquid. But some of the outer moons have taught us that a star is not the only source of warmth. Gravity itself can be a furnace. Take Europa, a moon of Jupiter roughly the size of our own moon, wrapped in a shell of ice. From a distance it looks like a cracked marble, its surface scored with a spiderweb of reddish-brown lines. But beneath that icy crust, kilometers deep, there is an ocean. Not a small one. Europa's hidden ocean may contain more than twice as much liquid water as every ocean on Earth combined. It stays liquid because Jupiter's immense gravity kneads and squeezes the moon as it orbits, flexing its interior, generating heat through friction, the way a paperclip grows warm when you bend it back and forth. That heat keeps the ocean from freezing solid, and where there is liquid water, warmth, and the right chemistry, there is at least the possibility of life. On Earth, in the crushing dark of our own deep oceans, entire ecosystems thrive around volcanic vents that no sunlight has ever reached, feeding on chemical energy welling up from below. If it can happen at the bottom of our seas, why not at the bottom of Europa's? Then there is Enceladus, a small moon of Saturn, gleaming white and innocent, one of the most reflective objects in the entire solar system. It too hides an ocean beneath its ice. And Enceladus does something astonishing. It leaks. From great cracks near its southern pole, enormous geysers erupt into space, jetting water vapor and ice grains hundreds of kilometers upward. A spacecraft actually flew through those plumes and tasted them, and what it found sent a shiver through everyone studying the data. The plumes contained water, salts, and complex organic molecules. They contained hydrogen gas, a possible food source for microbial life. Enceladus is spraying the contents of its buried ocean straight out into space, offering us a free sample of an alien sea. And that sample looks unnervingly like a place where something could be alive. We may not even need to drill through the ice. We may only need to fly through the spray and catch it. And there is Titan, the largest moon of Saturn, a world so bizarre it barely feels real. Titan has a thick atmosphere, thicker than Earth's, and it is the only place besides Earth where we know that stable liquid pools on the surface. But those liquids are not water. Titan is so cold, hundreds of degrees below freezing, that water there is hard as stone. Instead, it rains methane and ethane from an orange, hazy sky. Titan has rivers and lakes and seas of liquid hydrocarbons. It has weather, seasons, dunes of dark organic sand, and a slow chemistry so exotic that if life exists there, it would have to be built on rules utterly unlike our own. Titan is a reminder that our imagination has been too small. We keep looking for worlds like Earth, but the universe seems perfectly willing to try other recipes entirely. All of this, every planet and moon and frozen sea, belongs to a single star among hundreds of billions. And to understand where we truly are, we have to understand what a star actually is, how it lives and how it dies. Because the death of stars is not just a spectacle, it is the reason you exist. A star is born inside a cloud of gas and dust, one of the vast, cold nebulae that drift between the stars like continents of fog. Something disturbs the cloud, a passing shockwave perhaps, and it begins to collapse under its own gravity. As it falls inward, it heats up. The center grows denser and hotter, spinning, gathering, until at last the pressure and temperature in the core reach a threshold, and fusion ignites. In that instant, a star switches on. For the first time, its core begins fusing hydrogen into helium, pouring out light, and the outward push of that energy finally balances the inward crush of gravity. The star settles into a long, stable life, and it will burn steadily for millions or billions of years, depending on its size. Here lies one of the great counterintuitive truths of the cosmos. The biggest stars die youngest. A giant star burns through its fuel with reckless speed, blazing brilliant and blue, and may exhaust itself in just a few million years. A small, dim red star sips its fuel so slowly that it can burn for trillions of years, far longer than the universe has yet existed. Our own sun is somewhere in the middle. It has been shining for around 4.5 billion years, and it has roughly 5 billion more to go before its fuel begins to fail. When that day comes, the sun will not explode. It will swell. As the hydrogen in its core runs out, the balance between pressure and gravity will break, and the outer layers will bloat outward until the sun becomes a red giant, vast and bloated and cool, swallowing Mercury, swallowing Venus, and scorching the Earth to a lifeless cinder. Whatever we are by then, we will have needed to leave. But the truly enormous stars end their lives in a way that reshapes the galaxy itself. When a giant star exhausts its fuel, its core collapses in a fraction of a second, and the outer layers rebound in a titanic explosion called a supernova. For a few weeks, that single dying star can outshine an entire galaxy of 100 billion other stars combined. The explosion floods the surrounding space with light and unimaginable energy. And in the searing heat of that death, something crucial happens. The elements heavier than iron, the gold and silver and uranium, and the calcium in your bones, cannot be made in the calm core of an ordinary living star. They are forged only in the violence of stellar death, in supernovae, and in the collisions of the dense stellar corpses left behind. Every atom of iron in your blood, every atom of calcium in your teeth, every trace of gold anyone has ever worn, was manufactured inside a dying star and scattered across space in an explosion that happened long before the sun was born. Let that settle for a moment. The material that makes up your body was cooked in the hearts of ancient stars and blasted into the void, then drifted for ages through cold clouds of gas, gathered slowly into a new cloud, and finally condensed into the sun, the earth, the oceans, and eventually into you. You are, quite literally, assembled from the ashes of stars that died before there was anyone to mourn them. When you look up at the night sky, you are made of the same stuff you are looking at. The distance between you and the cosmos is not as great as it seems. You are the cosmos, folded into a shape that can wonder about itself. The corpses stars leave behind are among the strangest objects that exist. When a medium star like the sun dies, it gently sheds its outer layers and leaves behind a white dwarf, a super-dense ember the size of a planet, but as heavy as a star, slowly cooling over billions of years. But the giants leave behind something far more extreme. If the collapsing core is heavy enough, gravity crushes the atoms themselves, smashing protons and electrons together until only neutrons remain, packed so tightly that a single teaspoon of the resulting neutron star would weigh as much as a mountain. These city-sized corpses can spin hundreds of times per second, sweeping beams of radiation across space like cosmic lighthouses, so precise that we can set our clocks by their pulses. And if the collapsing core is heavier still, not even the packed neutrons can hold. Gravity wins completely, and matter collapses toward a single point, dragging space and time down with it, and a black hole is born. There is nothing in the universe quite as unsettling as a black hole. It is not a thing, exactly. It is a place where gravity has become so overwhelming that nothing, not even light, the fastest thing there is, can escape once it crosses a certain invisible boundary. That boundary is called the event horizon, and it is a point of no return in the most absolute sense the universe allows. Cross it, and you are gone. No signal, no light, no scream can ever climb back out. Everything about a black hole is defined by that terrible edge, the line between the universe you can leave and the region from which nothing returns. Approach one, and reality itself begins to bend. Gravity is not really a force pulling on you. It is a curving of space and time. And near a black hole, that curvature becomes so extreme that space folds and time slows. If you could watch a friend fall toward a black hole from a safe distance, you would never actually see them cross the horizon. As they fell, their clock would appear to tick slower and slower relative to yours. Their falling image would grow dimmer and redder, stretching, freezing, hovering forever at the edge. An afterimage burned onto the boundary of the abyss. From their own point of view, though, they would fall right in without pausing, crossing the horizon in an ordinary instant, never suspecting that to the outside universe they had become an eternal, fading ghost. Time near a black hole is not a shared truth. It splinters. What is a moment for one observer is an eternity for another. And should you fall too close, the black hole would kill you in a way so grotesque that scientists gave it an almost playful name: spaghettification. Because gravity grows so much stronger over even a short distance near a black hole, your feet, being closer, would be pulled far harder than your head. You would be stretched, drawn out into a long, thin thread of matter, torn apart atom by atom as you plunged toward the center. The larger the black hole, the gentler the crossing. The smaller ones would shred you long before you reached the horizon. Either way, the end is absolute. Whatever falls in is added to the mass of the whole and, as far as we can tell, is lost to the rest of existence forever. For a long time, black holes were only a prediction, a strange consequence of the mathematics of gravity that many scientists suspected could not truly exist in nature. They were too extreme, too monstrous. Then, one by one, we found them. We found them by their effects, by the way stars whipped around invisible companions at impossible speeds, by the searing radiation given off when gas spiraled inward and heated to millions of degrees before vanishing over the edge. And then, in a triumph that took a network of telescopes spanning the entire planet working together, as if the whole Earth were a single enormous eye, we did the impossible. We photographed one. The image showed a ring of glowing gas, blazing hot, wrapped around a perfect circle of absolute darkness, the shadow of an object so dense that light itself circles it like water spiraling down a drain. Seeing it for the first time, many of the people who had spent their lives searching wept. It was the silhouette of a thing that should have been impossible to see, a portrait of the edge of nothing. But the most staggering discovery of all was where the biggest black holes hide. At the center of our own galaxy, and at the center of nearly every large galaxy in the universe, there lurks a supermassive black hole. The one at the heart of the Milky Way has a mass millions of times greater than our Sun, crushed into a region no larger than our solar system. We have watched stars near it swing around it in tight, screaming orbits, moving at millions of kilometers per hour, held in the grip of something invisible and immense. These giant black holes are not rare accidents. They appear to be a fundamental feature of galaxies, a dark heart around which the entire wheel of stars turns. Our galaxy, everything you have ever seen in the night sky, is orbiting a monster. And somehow, that monster and the galaxy grew up together, their fates tangled in ways we are only beginning to understand. The universe found another way to reveal its black holes, one so subtle and so profound that confirming it stands among the greatest scientific feats in history. When two black holes spiral into each other and merge, the violence of that collision sends ripples through the fabric of space and time itself. Waves of stretching and squeezing that spread outward across the universe at the speed of light. These gravitational waves are almost unimaginably faint by the time they reach us. As one washes over the Earth, it stretches and compresses the entire planet, by an amount smaller than the width of a single atom. And yet we built machines patient and precise enough to feel it. Instruments that measure a change in length thousands of times smaller than the nucleus of an atom across a tunnel kilometers long. When the first signal arrived, it was the faint, rising chirp of two black holes, each far heavier than the sun, colliding more than 1 billion light-years away, an event that happened before there was complex life on Earth, its echo only now reaching us. In that moment, we grew a new sense. For all of history, we had only ever seen the universe. Now, for the first time, we could feel it tremble. Let us pull back now, away from these violent deaths and monstrous hearts, and consider the worlds that circle other stars, because for most of human history we could only guess whether they existed at all. We looked up at the stars and wondered if any of them held planets like ours, oceans like ours, perhaps eyes like ours looking back. For thousands of years it was pure speculation. Then, only a generation ago, we finally found the first planet orbiting another sun-like star, and the floodgates opened. We now know of thousands of them, and the count climbs every year, and the strangeness of what we have found dwarfs anything we imagined. Finding these worlds is a delicate art, because a planet is tiny and dark next to the blazing star it orbits, like a moth beside a searchlight from across a city. So mostly we do not see the planets directly. Instead, we watch for their shadows and their tugs. When a planet passes in front of its star, it blocks a minuscule fraction of the light, and if we watch carefully, we can catch that faint, regular dimming, a heartbeat of shadow repeating each time the planet completes an orbit. Or we watch the star wobble, pulled ever so slightly back and forth by the gravity of a planet circling it, betraying the presence of an unseen companion. From these whispers of dimming and wobbling, we have reconstructed entire solar systems we can never visit, mapping worlds by the shadows they cast. And what worlds they are! We have found planets orbiting so close to their stars that their years last only hours, their surfaces molten, oceans of glowing rock, winds of vaporized iron. We have found worlds where it may rain molten glass, blown sideways by winds faster than the speed of sound. We have found planets so light and puffy they would float on water, and others so dense they may be worlds of solid diamond, the compressed carbon hearts of dead stars' companions. We have found planets orbiting two suns at once, where you would cast twin shadows and watch a double sunset, and planets circling the rapid fire beams of a dead neutron star. We have even found rogue planets, worlds torn free of any star entirely, wandering the frozen dark of interstellar space alone, without a sun to warm them, drifting through the galaxy in perpetual night. But among all these exotic worlds, we keep searching for the quiet ones, the temperate ones, the planets that sit at just the right distance from their star, for water to remain liquid on the surface. The narrow band we call the habitable zone. And we have found them. We have found rocky worlds roughly the size of Earth, orbiting in that gentle band where a planet could hold oceans and rivers and rain. One nearby system holds 7 rocky worlds circling a small, cool red star, several of them in the temperate zone, so tightly packed that from the surface of one you could look up and see the neighboring planets hanging in the sky larger than the moon appears to us, close enough to make out their features. Whether any of them holds life we do not yet know, but they are there, real places, with real surfaces and real skies, waiting. The next great step is already beginning. When a planet passes in front of its star, a thin sliver of starlight filters through the planet's atmosphere on its way to us, and that light carries chemical fingerprints. Different gases absorb light in different, telltale ways. By spreading that filtered starlight into a spectrum, we can read what an alien atmosphere is made of from across the galaxy without ever going there. We are searching for particular combinations, gases that should not be able to coexist for long unless something keeps replenishing them. On Earth, oxygen fills the air only because living things continuously produce it. Without life, it would vanish into rock and rust within a geological blink. If we found an atmosphere rich in oxygen alongside other gases that living processes tend to produce, on a temperate rocky world, it would be the most electrifying discovery in the history of our species. Not proof, but a signal that would demand every telescope we have. Somewhere out there, that reading may be waiting in a spectrum we have not yet taken, which brings us to a question that grows heavier the more you think about it. The galaxy is old, unimaginably old. There has been more than enough time for life to arise, for civilizations to rise and spread, for the sky to fill with the signals and structures of countless others. There are hundreds of billions of stars in our galaxy alone, and most of them, we now know, have planets. Even if life is rare, even if intelligence is a long shot, the sheer number of chances should have produced someone, somewhere, long before us. So a simple, chilling question presents itself. Where is everyone? The universe should be teeming, and yet when we point our instruments at the sky and listen, we hear only silence. Vast, patient, absolute silence. This silence has a name, and it haunts everyone who studies the stars. Perhaps life is far rarer than we hope, and the leap from lifeless chemistry to a living cell is a needle-thin miracle that almost never happens. Perhaps life is common, but intelligence is not, and most worlds hold only oceans of microbes that never build a telescope or ask a question. Perhaps civilizations do arise, again and again, but they tend to destroy themselves, or fade, or simply have no reason to shout into the dark. Perhaps they are out there right now, but the distances are so crushing, and the timescales so vast, that two civilizations blinking into existence, within reach of each other, at the same brief moment in cosmic time, is like two fireflies flashing once each on opposite sides of an ocean, and expecting to see one another. We do not know the answer. And whether the answer is that we are surrounded by unheard neighbors, or that we are truly, terrifyingly alone, both possibilities are among the most profound anything could ever confront us with. Either the universe is full of others we have yet to meet, or this small blue world holds something so rare that it may exist nowhere else. Both should change the way we treat it. Now lift your gaze from single stars and single worlds, and take in the great structure that holds them all. Our sun and all its planets belong to a galaxy, an immense, slowly turning wheel of stars called the Milky Way. It contains something like a few 100 billion stars, bound together by gravity, spiraling around that central supermassive black hole. If you could rise far above it and look down, you would see a glowing pinwheel. Bright arms of stars and gas curling out from a dense golden core. The whole thing spanning 100,000 light years from edge to edge. Light, which crosses from the Earth to the Moon in a second, needs 100,000 years just to cross our own galaxy. And our sun is not at the center of this grandeur. It sits out in the quiet suburbs, on the inner edge of one of the spiral arms, roughly 2/3 of the way from the core to the rim, taking around 230 million years to complete a single orbit around the galactic center. The last time the sun was in its current position in the galaxy, the earliest dinosaurs were just appearing on Earth. We have not yet completed one galactic year since then. On a truly dark night, far from the glow of any city, you can see this galaxy edge on with your own eyes. It appears as a faint milky band arcing across the sky, a river of soft light, which is exactly how our ancestors saw it and named it. That pale band is the combined glow of countless stars too distant and too dense to separate. The disk of our own galaxy seen from the inside, from a position embedded within it. When you look at that band, you are looking down the length of the wheel you are riding on, toward the crowded heart of home. And with even a modest telescope, that soft glow shatters into thousands upon thousands of individual suns, each one potentially with worlds of its own, each one a story we will almost certainly never learn. And the Milky Way is not alone. It has companions, smaller galaxies orbiting it, and it belongs to a small cluster of galaxies bound together by gravity. And that cluster belongs to a larger structure, and that to a larger one still. Galaxies gather into groups, groups into clusters, clusters into vast superclusters, all strung along enormous filaments of matter that stretch across the universe like a cosmic web. Threads of galaxies wrapped around great empty voids, where almost nothing exists at all. Zoom far enough out, and the universe begins to look strangely alive, like the branching threads of a neural network, or the delicate tissue of something breathing. The largest structures we know of stretch across distances so vast that light would take billions of years to cross them. On that scale, entire galaxies, each holding hundreds of billions of stars, become mere glowing specks, like grains of luminous dust caught in a beam. Our nearest large galactic neighbor is a spiral much like our own, so far away that its light takes over 2 million years to reach us. When you look at it on a clear dark night as a faint smudge visible to the unaided eye, you are seeing the most distant object any human can perceive without a telescope, and you are seeing it as it was more than 2 million years ago, before our own species existed. And here is the astonishing part. That galaxy is falling toward us. Across the emptiness between us, gravity has taken hold, and the two great wheels of stars are drifting closer, gathering speed, on a collision course. In a few billion years, they will meet. But do not imagine a crash of grinding stars. Galaxies are mostly empty space, and the stars within them are so far apart that in all likelihood not a single star will directly strike another. Instead, the two galaxies will pass through each other, their shapes torn and stretched by gravity into vast streamers and arcs, before slowly settling, over hundreds of millions of years, into a single new galaxy, larger than either was before. Any world that survives to witness it will hang beneath a sky utterly transformed, the night blazing with the light of a merger between two great islands of stars. Yet for all we have mapped and measured, the deepest secret of the cosmos is that most of it is invisible to us, and we do not know what it is. When astronomers studied how galaxies spin, they found something impossible. The stars at the outer edges of galaxies were moving far too fast. Based on the visible matter, all the stars and gas we can see, those outer stars should have been flung off into space long ago, like a merry-go-round spinning so fast that the riders are thrown from their seats. Something was holding them in, some vast unseen source of gravity, far more massive than everything that glows. We call it dark matter, not because we understand it, but precisely because we do not. It gives off no light, absorbs no light, reflects nothing. It passes through ordinary matter, through planets, through you, without a trace. It is detectable only by its gravity, by the way it bends the paths of stars and warps the light of distant galaxies. And there is far more of it than there is of everything we can see. For every kilogram of familiar matter, the stars and planets and gas and living things, and all the shining stuff of the visible universe, there are several kilograms of this invisible substance, forming an unseen scaffolding on which the bright galaxies hang like ornaments. The universe we can see is only a faint decoration draped over a hidden structure we cannot perceive at all. And there is a deeper mystery still, stranger even than the dark matter. When we measure the universe on its grandest scale, we find that it is not simply sitting still, nor coasting to a gentle stop. The galaxies are rushing apart from one another, and the space between them is stretching, growing, carrying them outward. That much was startling enough, but then we discovered that this expansion is not slowing down, as gravity should demand. It is speeding up. Some form of energy woven into the emptiness of space itself seems to be pushing the universe apart, and pushing harder as time goes on. We call it dark energy, and it is the most abundant thing there is, dwarfing both the dark matter and the ordinary matter combined. And yet we cannot say what it is. It is the single largest component of the entire cosmos, and it remains almost a complete blank in our understanding. Sit with that for a moment. Nearly everything in the universe, when you add up the dark matter and the dark energy, is made of substances we have never held, never seen, and cannot yet explain. All the stars and worlds and galaxies, everything that shines, everything the eye has ever caught, is a thin, bright film floating on an ocean of the unknown. Our knowledge, vast as it feels, is a candle held up in a cathedral whose walls we cannot find. If humility has a home, it is here. We are a young species, only recently able to leave our own planet, peering out from a small world around an average star, in a quiet corner of one galaxy among trillions. And we have already discovered that the great majority of reality is hidden from us. Every answer we win reveals 10 new questions. Every telescope we build shows us that the darkness is deeper than we thought. This is not a discouraging thought. It is the most thrilling thing imaginable. It means the age of discovery is not behind us. It has barely begun. The greatest mysteries this universe holds are still out there, waiting, and the beings who solve them may not yet be born. To reach toward those mysteries, we build eyes of extraordinary power. There is a limit to what human vision can do, and long ago we shattered that limit with glass and mirrors, then shattered it again by lifting our telescopes above the blurring, shimmering blanket of the atmosphere and placing them in the clarity of space. From orbit, a telescope can stare into the dark without the twinkle and distortion that plague us on the ground. And what these instruments have shown us has rewritten the story of the universe again and again. In one famous experiment, astronomers pointed a space telescope at a patch of sky that looked completely empty, a spot no larger than a grain of sand held at arm's length, a piece of blackness where the eye sees nothing at all. They left the telescope staring at that emptiness, gathering light, for days. And when the image came back, that empty speck of sky was crowded with galaxies, thousands of them. Whole galaxies, each one holding hundreds of billions of stars, packed into a scrap of darkness so small it should have held nothing. Every direction we look, no matter how empty it seems, is like that. The sky is not sprinkled with galaxies. It is drowning in them. There are more galaxies in the observable universe than there are grains of sand on every beach and in every desert on Earth. And that is only the part we can see. The newest of our great eyes was built to look further and deeper than anything before it, tuned to catch the faint, stretched, reddened light of the most distant objects, light that has traveled across almost the entire reach of the observable universe to reach us. Because looking far away is the same as looking far back, these instruments are, in a sense, time machines. The farther out they see, the earlier the era they reveal. showing us galaxies as they were when they were young. When the universe itself was young, their light having journeyed for billions of years across the expanding dark to fall, at last, onto a mirror built by curious minds on a small planet. When those first images arrived, showing ancient galaxies in exquisite detail, glowing across almost incomprehensible gulfs of space and time, people around the world stopped and stared. There was something almost sacred in it, in the quiet audacity of a young species reaching out with glass and patience to touch light older than the ground beneath its feet. And still, we are only sampling. The observable universe, the region from which light has had time to reach us, is a sphere tens of billions of light years across, and it may be only a tiny fraction of a cosmos that stretches on far beyond, forever beyond the horizon of what we can ever see. There may be regions so distant that their light will never reach us, no matter how long we wait, because the space between us is stretching faster than the light can cross it. Whole galaxies, whole civilizations perhaps, are slipping permanently beyond our reach, disappearing over a horizon we cannot follow. The universe is not only vast, parts of it are becoming forever unknowable, walled off by the expansion of space itself. We live in a brief window, cosmically speaking, when we can still see the distant galaxies at all. Far in the future, they will have receded so far that they will vanish entirely. And any astronomers alive then, looking out, will see only their own local neighborhood, and might conclude that it is the whole of everything, never knowing what once filled the sky. That thought carries us into the strangest journey of all. The journey through time, into the deep future of the cosmos. Everything we have described, the blazing stars, the crowded galaxies, the busy chemistry of living worlds, belongs to what is, in the grand scheme, an early and vibrant chapter. The universe is young, and it is bright, and it is full. But it will not stay that way. Follow the timeline forward, far beyond anything human, and watch the cosmos change. If the laws of physics we know today continue to hold, the far future belongs to the small, slow stars. The great blue giants have long since burned out. New stars are still being born from the leftover gas, but more and more slowly, as the raw material is used up and locked away in dead remnants. Eventually the clouds run dry, and the last new star ignites. After that, no more will ever form. The bright, star-forming era of the universe, the age we happen to live in, will draw to a close, and the cosmos will be left with the stars that already exist, burning down one by one. The longest-lived among them, the small red dwarfs, will keep glowing faintly for trillions of years, far longer than the universe has existed so far, dim red embers in a darkening sky. But even they will fade in the end. Star by star, the lights will go out. These are timescales that make the mind reel. We speak casually of billions of years, but the deep future of the universe is measured in numbers so enormous that our usual words fail entirely. Compared to the full stretch of cosmic time that may lie ahead, the entire history of the universe until now, every star that has ever shone, every world that has ever formed, every living thing that has ever drawn breath, is only the faintest opening flicker, the first heartbeat of a story almost unimaginably long. We are living in the bright morning of the cosmos, when there are still stars, still fresh worlds, still the possibility of oceans and life and eyes to see. Whatever comes after, we are here now, in the age of light. And there is something almost unbearably precious in that. We did not arrive too late, when the sky had gone dark and cold. We arrived early, in the season of stars, with the whole spectacle still blazing above us. Of all the moments to be alive in the history of the universe, this is one of the richest. And so the question turns back toward us. Not the cosmos out there, but the small, warm-blooded creatures gazing up at it. What will we do with the fact that we can see all this? For nearly all of human existence, the stars were untouchable, painted lights on the roof of the world. Then, in a span of time so short it barely registers against the age of the Earth, we learned to fly, then to leave the atmosphere, then to walk on another world, then to send our machines to every planet in the solar system and beyond. We have a permanent outpost circling the Earth right now, a laboratory the size of a football field, where people from different nations live and work together in weightlessness, watching 16 sunrises and 16 sunsets every single day as they race around the planet. Up there, borders vanish. There are no lines on the Earth when you see it from orbit. Only a single, seamless, glowing world, wrapped in that impossibly thin skin of air, turning silently in the dark. Everyone who has seen it says the same thing. It changes you. It is impossible to look at the whole Earth at once, hanging alone in the blackness, and not feel both how small we are and how precious. The next chapters are already being written. There are plans, real and advancing, to return to the moon and stay this time, to build outposts, to learn how to live off another world's resources, to use it as a stepping stone. There are serious efforts to send people to Mars, to plant the first human footprints in that red dust, to begin the almost incomprehensibly difficult work of learning whether our species can become something that lives on more than one world. It will be brutally hard. Space does not forgive. The distances are punishing, the radiation is deadly, the isolation is crushing, and every system that keeps a human alive must work perfectly, far from any help, for months or years at a time. People will very likely die trying. They always have, on every frontier our species has ever crossed. And still we will go, because the same restlessness that drove our ancestors out of their first valleys, across seas and deserts and ice, drives us now toward the sky. It is not a choice so much as a nature. We are the animal that cannot stop looking over the horizon. Think of what it would mean. For all of history, everything any human has ever done, every empire, every song, every love and loss, every discovery, has happened on the surface of a single planet. Everyone you have ever known, everyone who has ever lived, shares this one small world. If we can take even the first real steps toward becoming a species that lives among the stars, it would be a threshold as great as the first life that crawled from the sea onto land. Not an escape from Earth, which will always be our home and our cradle, but an expansion of what it means to be alive at all. The universe is, as far as we can tell, mostly empty and mostly silent. To carry life and curiosity and the ability to wonder out into that emptiness would be to change the character of the cosmos itself, if only in one small corner of it. But we do not have to leave the planet to be part of this. Every one of us can look up, and in looking up, take part in the oldest human act there is. Long before writing, before agriculture, before cities, our ancestors lifted their faces to the night and watched the same stars we watch now. The patterns they traced in the sky, the stories they told about those patterns, the way they used the turning of the heavens to mark the seasons and steer their journeys, all of it grew from that simple upward gaze. The night sky is the one thing every human generation has shared, the common inheritance of everyone who has ever lived. The specific stars shift over the ages, drifting slowly as the whole sky wheels through its vast, slow turning. But the wonder does not shift. It is the same wonder, passed down unbroken across tens of thousands of years, From the first eyes that looked up in astonishment, to the eyes reading these words now. And there is so much still to find. We have not solved the mystery of what the dark matter is, the invisible substance that outweighs everything we can see. We have not explained the dark energy that is pulling the universe apart. We do not know whether life exists anywhere but here, whether the silence we hear means we are alone, or simply that we have not yet learned to listen properly. We do not know how common worlds like ours truly are, or whether, somewhere out among those billions of stars, there is an ocean under an alien sky where something is stirring. We do not know what lies at the very center of a black hole, where our understanding of space and time breaks down completely. We do not know whether our universe is all there is, or one of many, or a small part of something larger that we cannot yet imagine. Each of these is a door standing ajar, with darkness on the other side, and the promise of discovery within. Return for a moment to our own neighborhood, because it is not as calm as the stately diagrams suggest. The solar system is littered with debris, the rubble left over from its formation, and some of that rubble crosses our path. Asteroids, chunks of rock and metal ranging from pebbles to mountains, drift in their millions, mostly in the belt between Mars and Jupiter, but not entirely. Some swing on orbits that bring them near the Earth, and comets, those ghostly wanderers of ice and dust, fall in from the frozen outer reaches, blazing into long glowing tails as they near the sun, before swinging back out into the dark for centuries or millennia. For most of human history, these were omens, mysteries, streaks of fear across the sky. Now we understand them, and understanding them has revealed a sobering truth. The sky is not only beautiful, it is occasionally deadly. The surface of the moon tells the story plainly. It is scarred with craters, thousands upon thousands of them. The record of every impact it has suffered over billions of years, preserved perfectly, because the moon has no weather to erase them. The Earth has been struck just as often, but our air, our water, and our restless geology have healed most of the wounds, hiding them beneath forests and oceans and time. Yet the scars are there if you know where to look. Buried craters tens of kilometers wide, the fingerprints of ancient catastrophes. And one of those catastrophes changed the entire course of life on this planet. Long ago, an object perhaps 10 kilometers across, a mountain falling from the sky, struck the Earth with the force of billions of nuclear weapons. It threw so much dust and debris into the atmosphere that the sky darkened around the whole world. The plants withered without sunlight. The food chains collapsed, and the great reptiles that had ruled the Earth for well over 100 million years vanished, almost all of them, in a geological instant. From the ashes of that disaster, small furred survivors crept out, and over the ages that followed, those survivors gave rise to us. We exist, in part, because the sky fell once and cleared the stage. The same cosmos that gives can also take away, without warning and without malice, simply because we share our orbit with mountains of stone. This is not only ancient history. Smaller objects strike the Earth all the time. Most burn up harmlessly, the shooting stars you can see on any clear night, grains of cosmic dust flaring out in the upper atmosphere. But now and then something larger arrives. Not long ago, a rock only about 20 meters across entered the atmosphere over an inhabited region. And even though it exploded high in the air, rather than reaching the ground, the blast shattered windows across an entire city and injured hundreds of people, and almost no one had seen it coming. It came out of the direction of the sun, hidden in the glare. That single event was a wake-up call. For the first time in the history of life on Earth, a species has the ability to see these threats coming, and, perhaps, to do something about them. We have begun to catalog the larger asteroids whose paths cross ours, tracking them, calculating their orbits years and decades into the future. And we have taken the first real step toward planetary defense, deliberately crashing a spacecraft into a distant asteroid to see whether we could nudge its path. Whether we could, if we ever needed to, deflect a mountain from the sky. It worked. We changed the orbit of another world, however slightly. For the first time, the ancient pattern of helpless victims beneath a dangerous sky was broken. We are the first life on this planet that can look up, see the threat, and act. The sun itself, our source of all warmth and life, is not entirely benign either. It is a seething, violent star, and its surface churns with magnetic storms. Now and then it hurls out a colossal burst of charged particles, a cloud of solar plasma flung across space. When such a cloud sweeps past the Earth, it slams into our magnetic field, and most of the time the result is merely beautiful. The shimmering curtains of the auroras, glowing green and red and violet, dancing across the polar skies, as the particles funnel down along the magnetic field lines and light up the upper atmosphere. But a truly enormous solar storm is another matter. More than a century and a half ago, before we depended on electronics for everything, one of the largest solar storms ever recorded struck the Earth. The auroras blazed so brightly that people could read by their light in the middle of the night, and they were seen far from the poles, in regions that never witnessed them. Telegraph systems, the only electrical network of the age, sparked and failed. Some operators received shocks, and some found their equipment kept working even after they disconnected the batteries, running on the current induced by the storm itself. If a storm of that size struck today, in a world wrapped in power grids and satellites and delicate electronics, the damage could be staggering, knocking out electricity across continents. Our own life-giving star, calm and steady as it seems, is capable of reaching out and touching us in ways we are only beginning to prepare for. We live inside the atmosphere of a star, and we forget it at our peril. Now let us confront honestly the greatest barrier of all, the one that stands between us and the stars themselves: distance, and the stubborn cosmic speed limit of light. Nothing that carries matter or information can travel faster than light. And even light, the fastest thing there is, takes years to cross to the nearest star, and tens of thousands of years to cross the galaxy. Our fastest spacecraft, marvels of engineering that they are, move at a tiny fraction of light speed. At the pace our probes travel, a journey to even the closest star would take tens of thousands of years, longer than all of recorded history many times over. This is the hard, humbling truth at the center of every dream of reaching the stars. The universe is not built to our scale. It is built to a scale that dwarfs a human lifetime, so completely that the two can barely be spoken of in the same breath. And yet the human mind, refusing to be defeated, has imagined ways across the gulf. Perhaps one day we could build vessels that accelerate for years, pushing ever closer to the speed of light. And here the universe offers a genuine strangeness that is not fiction, but established physics. As you approach the speed of light, time itself slows for you relative to those you leave behind. A crew traveling near light speed might experience only a few years passing on board, while decades or centuries roll by on the Earth they left. In principle, a traveler could cross vast distances within a single lifetime, arriving young at a destination while ages passed at home. But the cost of pushing anything with mass that close to light speed is almost unimaginable, requiring amounts of energy far beyond anything we can currently produce. Others have imagined enormous ships that are entire worlds unto themselves, sealed vessels carrying communities of thousands, traveling for generations, so that those who arrive at a distant star would be the distant descendants of those who departed, born and living, and dying in transit, never having seen the world their ancestors left, or the world their children will reach. Whether we will ever build such things, no one knows. But that we imagine them at all, that we sketch out serious plans for crossing distances that would take longer than civilizations last, says something about the reach of our restlessness. We are a species that dreams in light years, and we have not only reached outward with machines, we have tried to speak on the 2 spacecraft now drifting beyond the edge of the solar system, the ones that opened this story. There is a message, carefully made, meant for anyone or anything that might one day find them. It is a record, a golden disc, engraved with instructions for how to play it, carrying sounds and images from Earth. There are greetings spoken in dozens of languages. There is music from around the world. There are the sounds of wind and rain and thunder, of birds and whales, of a heartbeat, of a kiss, of laughter. There are pictures of mountains and oceans, of people and children and cities. It is a portrait of a world and a species, sealed into a bottle and thrown into the largest ocean there is. The odds that anyone will ever find it are almost beyond calculation. The spacecraft will drift for millions of years, perhaps billions, through the empty dark between the stars, never coming close to another world, unless by the rarest chance. And yet we made it anyway. We could not resist the gesture. Something in us needed to say, into the vastness, we were here. We existed. We looked up, and we wondered, and we reached out, hoping that somewhere, sometime, someone would know that we had not simply stared at the dark in silence. We have also sent messages of a different kind, beamed outward as radio signals, deliberate broadcasts aimed at distant clusters of stars, encoded pictures of who we are and where we live. These signals travel at the speed of light, faster than any craft. But even so, they will take tens of thousands of years to arrive, and any reply, if one ever came, would take just as long to return. To send such a message is to speak to a future so distant that everyone who sent it, and their descendants for hundreds of generations, will be long gone before it even reaches its destination. It is a conversation conducted across a chasm of time so wide that no single life, no single civilization even, can hold both ends of it. And still we speak. There is a strange nobility in it, in casting words into the dark that we ourselves will never hear answered, trusting that the reaching itself is worth something. Meanwhile, out among the stars, the universe puts on displays of creation and destruction so grand that our human dramas shrink to nothing beside them. Somewhere right now, in a cold, dark cloud of gas and dust light years across, new stars are being born. These stellar nurseries are among the most beautiful objects in all of space. Vast glowing pillars and towers of gas, sculpted by the fierce winds and radiation of the young stars forming within them, lit from inside like cathedral windows. Within these clouds, gravity is patiently gathering material, drawing it together, spinning it up, building the cores of future suns. Around many of those forming stars, disks of leftover gas and dust swirl, and within those disks, grains collide and stick, growing from dust to pebbles, to boulders to planets. We are watching, right now in various clouds across the galaxy, the very process that once built our own sun and earth, replaying before our telescopes. Every solar system, including ours, began as one of these swirling disks around a newborn star. To look at a stellar nursery is to look at the birthplace of worlds, at the machinery that turns cold clouds into planets, and, on at least one occasion, into places where life could take hold. And at the other end of a star's life, beyond even the supernova, the universe holds phenomena so extreme they strain belief. When certain massive stars collapse, or when the dense corpses of stars collide, they can release, in a matter of seconds, more energy than the sun will produce in its entire lifetime of billions of years, focused into narrow beams that blast across the universe. These are the most violent explosions known, and if one were to occur close enough and pointed directly at us, its radiation could devastate a planet's atmosphere from many light years away. Fortunately, they are rare, and the ones we detect come from unimaginably far off, from ancient galaxies billions of light years distant, flashes of fury from the early universe, reaching us only now. There are also the quasars, the blazing hearts of distant galaxies, where supermassive black holes are feeding, dragging in enormous quantities of gas that heats to incandescence as it spirals toward the edge, blazing so brightly that a single one can outshine its entire host galaxy of hundreds of billions of stars, visible across almost the entire width of the observable universe. The most luminous objects we know of are not stars at all, but the glowing final cries of matter falling into the dark. Every so often, our own solar system receives a visitor from beyond, an object that did not form here at all, but drifted in from interstellar space, a wanderer that spent perhaps billions of years crossing the void between the stars before happening to pass through our neighborhood. We have detected a small number of these interstellar travelers now, tumbling silently through, briefly caught in the sun's glare, before continuing on their endless journey outward, never to return. Each one is a fragment of another star system, a piece of some distant world's birthplace, carrying who knows what history in its frozen heart. They remind us that space is not a set of isolated islands, but a connected ocean, that material drifts between the stars, that the galaxy shares its pieces around over the long, slow ages. Somewhere out there, a fragment of our own solar system, flung out long ago by the gravity of the giant planets, may be drifting through another star system right now, a piece of home lost among strangers. How did we come to know all of this? That, too, is part of the wonder. Not so very long ago, in the span of human history, people believed the Earth sat unmoving at the center of everything, with the sun and stars wheeling around it. It was a reasonable belief. That is exactly how it looks. The sun does appear to rise and cross the sky and set. The stars do seem to turn overhead each night. To realize that it is instead the Earth that turns and moves, that our world is not the fixed center, but a planet in motion around an ordinary star, took centuries of careful observation, painstaking measurement, brilliant reasoning, and the courage to trust the evidence over appearances. And each new understanding humbled us further. First, the Earth was displaced from the center. Then the sun was revealed to be just one star among the multitude. Then our galaxy was found to be just one among countless others. Then even the matter we are made of turned out to be a minority in a cosmos dominated by the invisible. Again and again, we have discovered that we are smaller and less central and more recently arrived than we believed. And yet, strangely, this shrinking of our physical importance has not shrunk us. It has enlarged us. For the same small creatures who turned out to occupy such a tiny place also turned out to be capable of comprehending the whole vast structure, of measuring the distances to the stars, of weighing invisible matter, of reconstructing the history of galaxies they can never touch. We are physically minuscule, and yet, in our capacity to understand, we are somehow large enough to hold the universe in our thoughts. Set against all this immensity, our own planet begins to look like something almost impossibly precious. We have now surveyed thousands of worlds and moons, near and far, and every single one of them is hostile to us, scorching or freezing, crushed under poisonous atmospheres, or exposed to lethal radiation, without breathable air, or drinkable water or ground you could safely walk upon. Not one of them, so far, is a place a human being could simply step out and live. And then, there is the Earth, a world with liquid water covering most of its surface, a breathable atmosphere, a temperature that stays within the narrow range where life flourishes, a magnetic field shielding us from the worst of the sun's fury, and a protective layer high in the atmosphere that filters out the deadly part of the sunlight. Everything had to be right, and everything here is right. The more alien worlds we find, the more extraordinary our own becomes. We did not fully appreciate the Earth until we went out and looked at the alternatives, and found them all barren. And the layer of life on this world is astonishingly thin. If you shrank the Earth to the size of an apple, the entire biosphere, the zone from the deepest ocean trenches where life exists to the highest reaches where a bird can fly, would be thinner than the apple's skin. Everything alive that we know of in the entire universe exists within that impossibly delicate film wrapped around one small rocky world. Every forest, every ocean full of fish, every insect and animal and human being, every thought that has ever been thought, is packed into a layer so thin that on the scale of the planet itself, it barely registers. That is the whole of the known living universe, a faint skin of green and blue on a speck of rock, orbiting an average star, in the outskirts of one galaxy among trillions. It is easy to feel diminished by that. But there is another way to see it. That thin film is, as far as we yet know, the rarest and most remarkable thing in all of creation. Stars are common. Galaxies are common. Black holes and nebulae and drifting worlds are everywhere. Life, so far, we have found in exactly one place. That makes the Earth not insignificant, but almost unbearably significant. A single lit window in an enormous dark house. And we are the ones lucky enough to be standing in the light. The universe is, for the most part, a place of terrible extremes and terrible emptiness. Between the galaxies, in the vast intergalactic voids, matter is spread so thin that there may be only a handful of atoms in a space larger than a house. A vacuum more perfect than anything we can create in any laboratory on Earth. The spaces between the stars are cold beyond human comprehension, only a few degrees above the lowest temperature that is physically possible, the temperature at which all motion nearly stops. And near the hearts of dying stars, in the flash of a supernova, temperatures soar to billions of degrees, hot enough to forge new elements in an instant. Pressures at the centers of the densest stellar corpses would crush any earthly material out of existence. The universe spans a range of conditions so enormous that our comfortable planet, with its gentle temperatures and liquid oceans and breathable air, occupies a razor-thin sliver of what is possible, a tiny oasis of moderation in a cosmos of unimaginable extremes. Everywhere else is either scorching or frozen, either crushing or empty. Here, and apparently almost nowhere else, the conditions are gentle enough for water to pool, for chemistry to grow complex, for cells to form, for creatures to arise who can look up and take it all in. And take it in we do, though we rarely stop to feel the strangeness of it. Every time you look at the stars, you are performing an act that borders on the miraculous. Light that left those stars years or centuries or millennia ago. Light that has traveled unimaginable distances across the empty dark, finally ends its journey by falling into your eye. And there, in the wet darkness inside your skull, it is turned into a signal, and the signal becomes a thought, and the thought becomes wonder. the universe has arranged, through some long chain of stars living and dying and scattering their elements, to produce a creature capable of receiving its ancient light and being moved by it. In you, in the simple act of looking up, the cosmos becomes aware of itself. The atoms forged in dead stars have assembled into something that can gaze back at the stars and comprehend, however imperfectly, where it came from. That is not a small thing. That may be, in fact, among the rarest and most precious things the universe has ever done. Consider what it means that to look out is to look back. Because light takes time to travel, everything you see in the sky is a message from the past, and the farther away it is, the older the message. The sun you see is 8 minutes old. The nearest stars are seen as they were years ago. The band of the Milky Way holds light from stars as they were centuries and millennia in the past. The neighboring galaxy is seen as it was before our species existed, and the most distant galaxies our great telescopes can find are seen as they were billions of years ago, their ancient light only now completing its immense journey. This means the night sky is not a snapshot of the present at all. It is a layered tapestry of different eras, all reaching us at once. Near things shown recent and far things shown ancient. The whole history of the cosmos folded into a single view. When you look up, you are not seeing the universe as it is. You are seeing 1,000 different moments of the past, stitched together, arriving together. A living museum of cosmic history hanging over your head every clear night, free for anyone who lifts their eyes. There is a peculiar comfort in this, and also a peculiar loneliness. The comfort is that nothing is ever truly gone. The light of things long changed or vanished still travels, still arrives, still shines. The loneliness is that we can never see the universe as it is right now, only as it was. If, at this very moment, something extraordinary were happening in that neighboring galaxy, we would not know for over 2 million years, because its light has that far to travel. We are always looking at ghosts, at echoes, at the past. And any beings out there, looking toward us, see our own world not as it is, but as it was, its light delayed by the same crossing. In a sense, the whole universe is a vast, slow conversation conducted across enormous gulfs of time, in which everyone is always speaking to everyone else's distant past. We are all, always, both ancient and current, depending on who is watching and how far away they stand. Even as you sit here, perfectly still, the cosmos is pouring through you unseen. Tiny particles from the sun and from distant exploding stars stream through the earth and everything on it in staggering numbers. Trillions of these ghostly particles pass through your body every second, day and night, and through the entire planet as if it were not there at all, so faint in their interaction with ordinary matter that they slip through solid rock as easily as through empty air. You are not sealed off from the universe. You are constantly, quietly, being passed through by it. The earth does not block the cosmos. The cosmos flows through the earth. High-energy particles from the depths of space, some from sources we still do not fully understand, strike the upper atmosphere and shatter into showers of secondary particles that rain down gently and endlessly, a soft, invisible cosmic drizzle that has fallen throughout all of history, unnoticed until we built instruments sensitive enough to catch it. We tend to imagine ourselves as separate from the sky, standing beneath it, looking up at it. But the truth is that we are inside it, immersed in it, threaded through by it at every moment. There is no boundary where the earth ends and space begins in any absolute sense. There is only atmosphere thinning into vacuum, and a planet swimming in a sea of radiation and particles that never stops. Now turn your gaze forward to what we are about to be able to see. The instruments we are building grow more powerful with each generation, and the next great leap is aimed squarely at the deepest question of all. Are we alone? The dream is to build telescopes so precise that they can not merely detect a distant Earth-like planet, but analyze the light of its atmosphere in fine detail, hunting for the chemical signatures that life leaves behind. Even more ambitiously, some designs aim to block out the overwhelming glare of a distant star so completely that we could photograph the faint planet beside it directly, capturing a single pale point of light that would be an entire world, another Earth perhaps, hanging beside its sun across dozens of light years of dark. Imagine the day such an image arrives. A single dot, a few pixels, resolved from the glare of an alien star. And in the spectrum of that dot, the fingerprint of oxygen, of water vapor, of the gases that on our own world are produced by living things. It would not be a photograph of forests or oceans. It would be far too distant for that. It would be a smudge of light. But that smudge could carry the most consequential news in human history: that we are not the only living world, that the universe has done here what it has done elsewhere, that life is not a fluke confined to a single planet, but a phenomenon that arises where the conditions allow. Or perhaps the search will keep coming up empty, world after world, showing only barren atmospheres, and the silence will deepen, and we will have to face the possibility that life truly is vanishingly rare, and that this small blue planet may hold something that exists in no other place we can ever reach. Either answer would be staggering. Either we are one voice among many in a living cosmos, or we are alone in a way that makes every living thing on Earth unspeakably precious. There is no comfortable middle. The question of whether we are alone is not idle curiosity. It is one of the deepest questions a thinking being can ask. And for the first time in the entire history of life on this planet, we are actually building the tools to answer it. Our generation, or the ones just after, may be the first to know. After all the ages of guessing and wondering and looking up in ignorance, someone, before very long, is going to find out. Think of how astonishing that is. For hundreds of thousands of years, human beings looked up at the same stars and could only wonder. They had no way to know how far the stars were, what they were made of, whether they held worlds, whether anything looked back. They built stories and myths to fill the silence, because they had nothing else. And now, within a few short generations, we have measured the distances, weighed the stars, discovered the worlds, and begun to sniff the air of planets orbiting other suns. The gap between total ignorance and the edge of answering the oldest question there is has been crossed in an eye blink of history. We happen to be alive at the exact moment when the wondering is finally turning into knowing. Of all the countless generations who gazed up and asked, we are among the first who may actually hear the universe answer. And whatever the answer turns out to be, the searching itself has already given us something irreplaceable. It has given us perspective. To study the cosmos is to be reminded, gently and constantly, of the true size of things. And against that scale, so much of what divides us here on the ground begins to look very small. The lines we draw across the map of the Earth do not appear from orbit. The quarrels that consume us would not register from the surface of the moon, let alone from the distance of Mars, where the whole Earth shrinks to a single bright point in a black sky, a point on which everyone who has ever lived was born, loved, struggled, and died. From far enough away, our entire world, with all its history and all its noise, is one small dot, one pixel of pale light. And that dot is all we have. There is no other refuge in reach, no backup, no second home waiting nearby. Every future we might have, every story yet to be lived, depends for now on this one fragile oasis. The cosmos, in all its terrifying grandeur, does not offer us a spare. Perhaps that is the deepest lesson the stars have to teach. Not that we are small, though we are. Not that the universe is vast and old and strange, though it is all of those things beyond our capacity to feel. The deepest lesson may be about care. When you understand how rare a living world appears to be, how thin the film of life is, how hostile nearly every other place we have found turns out to be, you begin to see this planet differently, not as a given, not as an endlessly renewable stage for our dramas, but as something extraordinary and possibly unique, entrusted to a species that has only just become powerful enough to protect it or to ruin it. The same knowledge that lets us reach toward Mars and photograph black holes and read the atmospheres of distant worlds also lets us see, with sobering clarity, just how precious and precarious our own situation is. To look outward, in the end, teaches us to look homeward with new eyes. Consider, once more, the sheer abundance of it all, because the numbers themselves are a kind of poetry that no imagination can fully answer. Our galaxy holds hundreds of billions of stars, and each one is a sun, and most of them, we now believe, are circled by planets. That means there are, in our galaxy alone, likely more planets than there are people who have ever lived on Earth, many times over. And our galaxy is one among an estimated 2 trillion galaxies in the observable universe. Multiply those together, and you arrive at a number of worlds so vast that writing it out would be meaningless. A figure with more zeros than the mind can track. Somewhere in that ocean of worlds, there are almost certainly planets more beautiful than any we have seen, with skies of colors we have no names for, with mountains taller than any on Earth, with oceans and storms and sunsets unfolding right now, in real time, entirely unwatched by any eye. There are worlds where it is dawn this instant, and worlds where it is deep night, worlds being born, and worlds growing old, and the overwhelming majority of them will never be seen by anyone, their beauty spent in perfect solitude across the eons. The universe is prodigal beyond reason. It makes wonders by the trillion, and shows them to no one. And into that vastness, from one small planet, a species has begun, tentatively, to look. Each of those stars scattered across the night is not a static point, but a place with a history as rich as our own suns. Each was born in a collapsing cloud, ignited, and has been burning steadily for millions or billions of years. And each will one day die, some quietly, some in unimaginable violence. Some of those stars are older than our sun, some far younger. Some have already given rise to planets that formed and cooled, and perhaps grew oceans long before the Earth existed. If life is at all common, then there have been living worlds that arose, flourished, and vanished entirely before our planet had even finished forming. There may have been civilizations that rose and fell in the deep past, whose light reached an empty Earth where nothing yet lived to see it, whose ruins now drift cold and silent around dead stars we will never identify. The universe has had a very long time to try. We are, on the cosmic timescale, extraordinarily recent arrivals, latecomers to a story already ancient beyond measure. And that thought, rather than making us feel unimportant, ought to fill us with a fierce curiosity. We have walked into the middle of the grandest tale there is, and we are only just learning to read the language it is written in. And still, out there in the dark, the two small travelers keep falling outward, the ones that began this story, carrying their golden records and their dying batteries into the space between the stars. Their instruments are shutting down now, one by one, as their power fades, and before long they will fall silent completely, unable to send back even a whisper. But they will not stop. They will keep coasting, cold and dark and mute, for millions of years, drifting through the emptiness, outlasting the very civilization that built them, outlasting perhaps the human species itself. Long after everyone reading this is gone, long after the memory of our age has faded, those little machines will still be out there, tumbling slowly through the interstellar dark, carrying the sounds of our oceans and the greetings of our languages, and the picture of a world where, once, matter woke up and looked at the stars. They are the farthest flung expression of the oldest human impulse, to reach, to wonder, to leave a mark, to say into the silence that we were here. That impulse did not begin with rockets, and it will not end with us. It began with the first human, who looked up at a sky full of unexplained lights and felt something stir, some mixture of fear and awe and longing that has never left our species since. It ran through every generation that mapped the constellations, that tracked the wandering planets, that dreamed of what the lights might be. It drove the ones who first suggested, against all common sense, that the Earth might move, and the ones who ground the first lenses and turned them upward, and were astonished by what they saw. It carried us to the moon, and sent our machines across the solar system, and taught us to weigh the invisible and read the ancient light. And it lives in you, in the simple fact that a story about distant stars and dying suns and worlds we will never touch can hold your attention and stir your heart. That stirring is the same stirring our most distant ancestors felt beneath the same eternal sky. You are the current keeper of an unbroken chain of wonder that stretches back to the very beginning of what it means to be human. There is one more thing worth holding on to before we turn our eyes back to the sky, and it is this: almost nothing we have learned about the cosmos was discovered by a single person alone. The image of the black hole came from telescopes on several continents, operated by hundreds of people. Their data combined into a single picture no one instrument could have made. The detection of ripples in space and time required thousands of minds working for decades, building machines of impossible sensitivity, refusing to give up through years of silence before the first signal finally arrived. The rovers crawling across Mars are guided by teams who wake each day on a schedule set by another planet's clock. The great telescopes are built by nations pooling their effort, by engineers and scientists and workers who will never meet most of the others whose labor makes the discovery possible. To reach the stars, even with our instruments, we have had to learn to reach toward one another. The exploration of space is, quietly, one of the largest cooperative efforts our species has ever undertaken. A project so big that no individual, no institution, no single generation could accomplish it. It is passed hand to hand, mind to mind, from those who begin the work to those who will finish it long after the beginners are gone. The knowledge we now hold was built by people who accepted that they would not live to see where their questions led, and gave their lives to the asking anyway. That, too, is part of the wonder. The universe is not only out there, immense and cold and ancient. It is also in here, in the shared human effort to understand it, in the patience of those who spend a lifetime studying a single moon or a single kind of star, in the awe of a child seeing the rings of a distant planet for the first time through a small telescope in a backyard. The cosmos gives us its extremes, its violence, its unimaginable scales, but it also gives us a reason to work together, to be curious, to look beyond ourselves and our brief moment. And the more we learn, the more we find that the universe is not a collection of separate facts, but a single connected story, in which the death of ancient stars gives rise to new worlds, in which the same physics that shapes a galaxy shapes a snowflake, in which the light of the beginning still travels through us today. Everything is woven together, across distances and ages we can barely grasp, into one vast unfolding whole, and we are a part of that whole, aware of it, marveling at it, adding our own small chapter to a tale that was already ancient before we arrived, and will continue long after we are gone. We stand, then, at a remarkable place in that tale. Behind us lie all the generations who looked up and could only wonder. Ahead of us lie generations who may know things we cannot yet imagine, who may walk on other worlds, who may finally learn whether the universe is empty or full of life. And here, in between, in this narrow, bright window of history, we are the ones who have learned enough to understand how much we do not know, and who still have every great question open before us. That is not a burden. It is a gift almost beyond measure. To be alive now, in the age when the stars are giving up their secrets one by one, when every year brings a discovery that would have seemed like magic to the people who came before, is to have been handed a front row seat to the greatest show there has ever been, and the only ticket it requires is the willingness to keep looking, and to keep wondering, and to remember, always, that the immensity above us is not a thing apart from us, but the very place we come from. So here is the invitation, the only real conclusion a story like this can have. Go outside, on the next clear night, away from the glare of the lights if you can, and look up. Let your eyes adjust to the dark, and watch as more and more stars emerge, dozens becoming hundreds, becoming thousands. And know, as you look, what you are truly seeing. Not lamps on a ceiling, but suns, countless suns, each unthinkably far, each pouring out light that has traveled for years or ages to reach precisely your eye at precisely this moment. Know that many of them hold worlds. Know that the soft band arcing across the sky is the edge of your own galaxy seen from within. 100,000 light years of stars. Know that beyond the farthest star you can see lie billions of galaxies you cannot, each one another island of hundreds of billions of suns. Know that the light entering your eyes is ancient, that you are looking into the deep past, that you are gazing at a museum of cosmic history, laid out above you every single night, free and open to anyone who bothers to lift their face. And know, above all, that you are not separate from any of it. The iron in your blood, the calcium in your bones, the very atoms that make up your body, were forged in the hearts of stars that lived and died long before the sun was born, scattered across space in explosions of unimaginable violence, gathered again over the ages into the world that made you. You are made of the same material as the stars you are looking at. You are the universe grown complex enough to contemplate itself, matter that has arranged itself, against staggering odds, into a form that can wonder where it came from and where it is going. The distance between you and the cosmos was never real. There is no gap to cross. You are already part of the great story, a living thread of it, a place where the ancient light finally arrives and becomes a thought. The universe is vast beyond comprehension, old beyond feeling, strange beyond imagination, and mostly silent, mostly empty, mostly dark. And yet, on at least one small world, in at least one brief and shining moment, it produced beings who could look out into all that immensity and, rather than being crushed by it, be lifted by it, be filled with a curiosity and a longing that no distance can contain. We do not yet know how far that curiosity will carry us. We do not know whether we will one day walk beneath other suns, or find that we were never alone, or discover that we are rarer and more precious than we ever dared believe. What we do know is that the looking has already begun. that the reaching has already started, that the questions are being asked, and that the answers, whatever they are, lie waiting in the same dark sky that has watched over every human who has ever lived. The stars have been patient for a very long time. They will wait a little longer, while we learn to understand them. And every night they return, faithful and ancient and unspeakably beautiful. An open invitation written in light across the whole of the sky, asking us only to look up, and to keep wondering, and never to stop reaching toward the vast and glittering unknown that is, in the end, our home.